Imagine a world where your electronic devices could not power on consistently. What if the alternating current from your wall outlet never smoothly transformed into the direct current those devices need to operate? Load resistance is absolutely vital for the proper function of any rectifier circuit and for achieving a stable, usable direct current output. Without it, the entire conversion process becomes unpredictable and often unmanageable. The fundamental purpose of a rectifier is to convert alternating current, or AC, into pulsating direct current, or DC. Diodes within the rectifier allow current to flow primarily in one direction. The load resistance connected to the rectifier's output acts as the component that actually draws this direct current. It dictates how much current flows through the rectifier circuit, which in turn influences the voltage drop across the diodes and the overall shape of the output waveform. A very low load resistance draws a high current, causing more voltage drop and increased stress on the diodes, while a very high load resistance draws little current, potentially leading to higher and regulated output voltages if filtering is not perfectly matched. For engineers, understanding the specific load resistance or the expected load range is paramount when designing a rectifier. It helps in selecting the correct types of diodes, determining the appropriate capacitance for filtering, and even sizing heat sinks to dissipate power efficiently. By correctly accounting for the load, you can ensure your direct current supply delivers consistent voltage under various operating conditions. This also involves considering the power rating of the load to prevent component overheating or failure. A key concept in this area is rectifier regulation, which quantifies how much the output direct current voltage changes as the load current varies. An ideal rectifier would have perfect regulation, meaning its output voltage stays constant regardless of the current drawn by the load. Real-world rectifiers, however, exhibit some degree of voltage drop as the load becomes heavier, meaning it draws more current. Conversely, a lighter load draws less current, leading to a smaller voltage drop. This intrinsic behavior due to the internal resistance of the rectifier and its components makes the load resistance a critical design parameter. Ultimately, load resistance is not just another component in a rectifier circuit. It is the fundamental factor that defines how well the rectifier performs. It dictates the current flow, impacts voltage stability, and influences the effectiveness of output filtering. By understanding and properly accounting for the load, engineers can design robust and reliable direct current power supplies that efficiently convert alternating current into the stable power our electronics depend on.